家演示了一些物体运动的现象。接下来呢，我要给大家
Newton had 3 basic laws of motion that changed our lives forever, and this one is based on which?
I think all 3 of those in play. Newton had 3 basic laws.
同学们看，
And all the 3
这是一个我们在太空
So
中
Newton's laws of motion were considered the best mechanics law until Albert Einstein's relative gravity came into being. Is that correct?
如果在地
I
面
think I would
此
say
时水
most
肯定
physicists
是会流下来
still
的，
consider Newton's
但
law
是
to be the
在
best
太空
because that's
湿
how
度
we
环
start
境
all
下，
science and
水是不会
engineering.
自己流出来
He was
的
the。pioneer in classic mechanics. And now it's time to
我
play
想
with
如果诗人
food.
李白在天宫中生活，大概他就写不出飞流直下3000尺的诗句了，因为在失重状态下
down 3,000 尺 because in a weightless motion, it is impossible to have a cascade.
接下来呢，我要挤出一个
Now I will squeeze a little droplet.
同学们，你们看到这个可爱的
Look at
漂亮的
these
小水
lovely, beautiful
有没有
little
想到
droplets.
晶莹剔透这个词呢？
Does it remind you the word translucent?
把它们串成一串饰金项链。
I would like to make a few more and make a necklace for you.
好，为了避免它
Okay.
到处乱飞，我要用独特的方式
In
来
order
收集
to
它。
avoid it from floating around, I will retrieve it in a very special way.
正好得润润嗓子。
I can just have some drink to clear my throat.
So this demonstration shows 2 important concepts. It's one is no gravity, the other one is surface tension in
这
water.
是一个
So we're talking about interdisciplinary
这是我们
here.
喝的
Yes.
普通水。
It's not just one aspect of physics, but they combine different rules together.
Yes.
细的看哦。首先，我把水袋
First of all, I will open the bag containing the water,
金属圈
and then I will put the metal ring in it
袋里，
very slowly,
轻轻的。
and then very gently I will pull it out.
同学们，见证奇迹的
Okay,
时刻
everybody,
到了。
this is where magic
我们做成了一
happens.
个漂亮的
I
水
made
膜
a very beautiful water film.
Is this the same that would happen on the ground?
在
I mean,
失
back
重
on
状态
Earth?
下，普通水
Sometimes
也可以
we
制
can
成
do
这
so.
么大的水膜。
If
这在地面上
if the size
是
is
很
small
难做
enough,
到的，
because
因为在地面上
I just
有重
mentioned
力
about the
的影
surface
响
tension.
水膜一
So
出水
when
就容易破
the
裂，
2 different materials
而在
in
太空
contact,
中由于
they
处于
can
失
reduce
重
the
状态
surface
水
energy.
的表
So
面张
you
力
reduce
就
the
会
surface tension.
减身为
So you see the membrane of water membranes sticking to the original
那
steel
这个水膜
cycles. It's because of the
我们来
interface between water and the steel. They apply tension to the membrane, and it's like
我
stretching
们看到了，
a sheet.
是我来回的晃动它。
And just a little reference here, elasticity is a physical property of materials which return to their original shape after they are
不
deformed.
过这个小水滴，我们要用吸水纸把它给收集
And
好。
I remember back in school, teachers would ask us why we can make bubbles out of soap water or why mosquitoes can stand on the surface of water.
That's all because of the surface tension coming into play.
Right.
接下来呢，我要试着
Next,
把
I
一
will
个
try
中国
to
结
press a Chinese knot
水膜的表面，
onto the water
看
film
它能不
and
能
see
承受住
if
这
it
个
can
水膜
sustain
结。
this Chinese knot.
好，现在把中国
Okay.
结慢慢的
We press the Chinese knot gently onto the
Wow.
film.
接上
There
了
we。go. Isn't it amazing?
Oh, the water membrane seems undestroyable.
看来这个水膜还是
So this water film is quite solid.
Oh, I think our astronaut is better defined as a magician other than a teacher.
在太空中，由于处于失
In
重状态
space,
我们见
because
到了
we're
很多
experiencing
地
zero
面上
gravity,
难以见到的
we
现
have
象。
a lot of phenomenon that is
接下
rarely
来
seen
还
on
有
the Earth,
更神奇的，
and more magic will come later. Do you want to witness that? Let's try some.
We're now about 25 minutes into this class, and I'm already fascinated. If you've just joined us, you're watching our live coverage from China's of China's first space class. China's second woman astronaut, Wang Yaping, is now performing some physical experiments, and back on Earth, 60 million teachers and students are watching it live across China. And earlier in this class, she performed experiments based on Newton's second law of motion. And now, as our teacher explained, is water tension.
那如果我们往水膜上加
So,
水，
if we
它会出
put
现
more
什么
water
样的
onto the
变化呢？
film, what will happen?
现在
Now,
一点一点的往水膜上
I will slowly inject water onto the film.
现在水膜
Now,
一点一点的
The
变厚
film is becoming thicker and thicker.
So, Mr. Wei, does this water membrane, does it burst at all in space?
If there is no external disturbance, they will remain in shape. That's mainly because you can see that if we add small droplets into the big one,
But
it will
yes,
keep
that's also an
growing.
outside force.
Right. It's basically because if they form one big sphere, and if we compare the surface area, which is proportional to the energy, so they try to minimize the surface area. So if you
哇哦，
break this
现在
into two parts,
水膜
you
已经变成
generate
了一个
extra
亮
surface
晶晶的
area.
大水
So that's
球
not comfortable to the
那同学
system.
们
So they
在
try
地
to
面上
bring
你们都
together
做到吗
and？ stay in the lowest energy level.
So, it's really amazing to see how a water membrane
同
has
学们，
become
现在你
a
可以
crystal
看
ball.
到水球的中间有很多小气泡，
You can see there are some little bubbles in this water sphere.
因为
Do you
在
know
我们
why?
刚才注水用的
It is
饮
because
水袋
just
中
now when we
本
are
身就存在着
injecting the
很多小
water,
气泡，
this water bag
现在
contains some
把小气泡
airs,
都抽出
some
来。
air. So now we are trying to get these bubbles out.
There's no way that's going to happen on Earth.
That's true. So we usually see the
你们看
bubbles
这个水球 像这
flow
样透
out
出，
to the
透过
surface
它，
and then
我们还
burst.
可以看到我的倒影呢。
There's the reflection of our teacher in that water membrane. Yanqing, are you amazed? Are you fascinated by this class?
It's really amazing. Mr. Wei, is this phenomenon called the cohesion of water? Is that
It's
part of?
yes, part of. It's mainly the surface tension.
我要用注射器
It's quite difficult to remember all the terminology relating to
有一个
physics.
气泡。
Now we have another big bubble inside. Oops.
泡破了。没关系
So, yes, the bubbles can burst.
注一个
And now the teacher is injecting another bubble inside.
You can see the resistance when the needle, they try to pull the needle out of the water. You can see the resistance and they will change the shape.
Right.
It's because of the adhesion between the needle surface and the water.
That's one tough crystal ball.
You see, the two bubbles did not become one, and they exist separately. So we can see there are different phenomena in different environments. And now we are getting these bubbles out.
The bubbles out of the big one. It's unbelievable. You can basically do anything to that fragile water ball. So last time in the Shenzhou 9 mission last year, China's first female astronaut, Liu Yang, she performed a set of biological experiments, and this time the physical one.
I think the target for this time is try to inspire our young generations for the interest in outer space explorations. You can understand that we are facing all kinds of challenges, and we do need more engineers and science devoted their life into this field.
Now, Yanqing, are you considering a change of major?
I will consider that.
So really, this is a perfect combination of education and space exploration.
Yes.
You can see the red liquid is spreading out in this water ball.
So before the launching the mission, lots of scientists are actually involved heavily in such objects. They try to design experiments which can be doable in space, and also they need to somehow validate existing theories or exploring new physics.
Now all of a sudden the water ball has turned red.
Okay, let's have a close-up of this red water ball and enjoy this beauty.
This is really pretty. It seems that the color is floating inside the water ball.
I love to play with bubble when I was young. I think if I would have a bubble like this, I would be happy for all the day.
You will be very interested in physics if it isn't first. So you said one of the teachers on the ground was your physics teacher back in school.
Yeah.
The lady or the gentleman?
The lady, the female one.
The lady. Now where is that water ball?
Absorbing the water ball by paper.
So it's gone.
Yeah.